Welcome to this Frequency Matters podcast. I'm Eric Hyam, and I'm here with Pat Hindle. In this episode, we're going to talk to Earl Lum, the president of EJL Wireless Research, to get his views on developments and trends in the wireless infrastructure markets. So welcome, Earl. It's good to catch up with you.
Thanks for having me here.
We've got Mobile World Congress starting in a little less than 2 weeks when we're recording this. What's your focus for this year's MWC, and what are you looking for, and what do you expect to see?
So my focus this year in going to the lovely city of Barcelona is, number one, to not get mugged like I did last year. Secondly, my focus is really going to be looking at antennas, at the new radios that are coming out, both macro, multi-band radios, as well as all of the latest massive MIMO wideband radios that are coming out. And I'm certainly going to expect to see some 6 gigahertz products from people, as well as some potentially, FWA, FR3 band types of products that I saw last year and out of the Samsung booth. And additionally, I think, what is the chatter amongst all the operators? How are they viewing, especially in Europe, with the top 4 or 5 guys and their whole push towards Open RAN? Where is that moving forward? And specifically, I think the biggest proponent out there has been Vodafone. So there is a new tender out for Vodafone's latest modernization project called Project Spring 6. And the question was always 30% of that in the European markets were supposedly allocated for Open RAN, and are they that close to picking a winner or winners of that tender, or where are we? And then where are the other operators, specifically the Germans, who still want to keep Huawei in their network, but are trying to go the Open RAN approach and keeping Huawei in their network? And how does that impact the overall dynamics over there in Europe for these operators? And then obviously AI, or I think automation is probably a better word, and machine learning, specifically if we're looking at RAN. We're not really looking at chatbots necessarily to figure out what the channel conditions are for a radio. But we're looking at how can we automate and do a better job of that. And I'm sure everyone's going to have their spin on AI over there. And I'm looking forward to seeing what that is.
So you mentioned Open RAN, and we did talk to you about 6 months ago on that topic, and you weren't a very enthusiastic supporter. So things started last year with AT&T releasing a big contract, but the activity seems to be slower as the year went on. And I think your thoughts were confirmed. Where does this activity stand now? What are you hearing with things like AI RAN? Is this just like a rebranding of the same idea?
So I think Open RAN continues to move forward. The real issue is at what level and with whom. And like I mentioned before, Vodafone is continuing to move forward with that. I think now with their previous head, their Open RAN initiative now at Verizon. What does that mean from Verizon's perspective regarding Open RAN? And I think there's still a lot of desire from the mobile operator, but I think it's important to let everyone know who's listening or viewing this podcast. The fact is, you have to be on par with everyone that's already delivering products as an incumbent. And the only thing that I've seen that's really on par at this point is a macro 4T4R radio, whether it's single band or multi-band. And so that part of it is pretty easy to do on the Open RAN. We saw this potential hijacking by Ericsson of Open RAN Massive MIMO with their additional flavor of Massive MIMO that is what they're bringing to the table and to the specs. And that has caused a lot of concern, because it means a redesign of everything for everyone else other than Ericsson. But if we look at 4T4R macros, you see TELUS having picked Blue Waves Mobility out of Canada. We see AT&T having chosen Mavenir and Fujitsu. But I think those were disappointments in that those were small cells. They were not even macros. And so what I'm seeing is orders for products that are not your primetime big league types of products that would I think everyone was hoping for. And now the question is, after all of the R&D and effort, and you end up with a bunch of macro 4T radios or 4T for our small cells that are dual band, does that pay for all of the R&D that you put into designing all of these products? And I think, again, the macro side will probably continue to see wins from some of the Open RAN players in that market. But outside of Samsung or Ericsson winning in Open RAN massive MIMO, we really haven't seen that take place in a substantial way. And that's where the money is. That's where all the fame and glory will be. And until we see that, my belief is that we're still not ready for prime time. Additionally, I think a lot of the focus is shifted away from the hardware to the software. So most of the guys in the Open RAN community are talking about the orchestration layer or the SMO part of Open RAN and the software of Open RAN more so than the actual hardware side. So if that's the case, then for all of the RF guys that are making radios out there who are not doing the SMO layer, what does that mean for them? And so I'm going to be trying to find every guy that's not doing Open RAN small cells, because that's not my focus, but doing Open RAN macro units and seeing what do they have that is worthy of me caring. What differentiates them other than someone's trying to subsidize them because they're in this particular country and they want to develop that technology for that country.
Yeah, that's interesting. So you mentioned this a moment ago, and we're hearing a lot about AI always. We have been for a while now. What are the real world applications for AI and wireless infrastructure? How widely is it being deployed, and what sort of applications?
I think the low-hanging fruit for AI has already been implemented, which was energy savings. Huawei and I think ZTE both several years ago introduced this idea of 0 bits, 0 watts. If I'm not transmitting anything, I shouldn't have to consume any amount of power. That's obviously not realistic because there's idle modes on everything and you can't just shut everything down. But they've gotten pretty good at where I think on a massive MIMO radio now, if you put it into deep, comatose level of sleep, then it's less than 5 watts. And then you snap that back on when you need to. So there's a lot of, let's say, for example, Ericsson has a community for their apps for Open RAN. And there's a lot of players there that have AI capability and such. But energy has been something that's already been initiated by every OEM out there with their own products. It's not open. And all of their products already can be put into deep sleep. So for a third-party person to come in and to offer a better deep sleep seems unlikely or seems like it's after the fact. I'm not sure how that would be better than the incumbent OEM's product. And certainly for deep sleep, I don't think you need to be a physicist or a rocket scientist to figure out at 3 a.m. that I should be turning beams off my massive MIMO radio, etc. So I think all of that's been kind of milked already. Now the question is what else can you do with AI in the RAN community? And certainly is a big push in release 18, 19, and beyond for 3GPP and also for 6G. And then that is primarily on channel conditions and things that maybe I can do a better job in understanding how much noise is in my channel. How can I squeak out whatever that is that's going to give me a better transmit, or more importantly, these days on the receiver side, everyone's really focused on uplink today and not so much on the transmit because of the limitations of the phones and of the handsets and how much power they can transmit. So everything is about the cell edge. How do we get better cell edge in terms of C-band? And do we do dual band in terms of I'm using mid-band 2.1 or 1.9 for the uplink, and I'm using the C-band for the downlink so that the cell is roughly about the same in terms of the perspective of the handset. So I think a lot of the AI is going to be focused on automating cells in terms of if I need to change software, if I need to do anything with the antenna beams, that once I move one beam, I'm going to touch 6 other beams, and then it'll touch 1,000 other beams. And that is not something that could be manually done. So I think the AI part of SON is where we're probably going to see a lot of focus in terms of automation and some of that that we were trying to do many, many years ago, but it didn't have the boosted performance potentially from AI to be able to allow that. I think those are some of the not sexy, but nitty gritty things that a mobile operator cares about in terms of their operational performance. And I think that's really going to be the focus, is efficiency. How do I use AI to improve my network's efficiency whatever level, whether it's maintenance, whether it is on digital twinning the towers to know exactly what I have by using drones, etc., or just being able to more efficiently run my network in whatever way. I think that's really where the operators realize that those are easy, low-hanging fruit to attack and to pick relative to some other very potentially lofty goals of I'm going to have a GPU at my base station site, which is what NVIDIA would love, but there's not enough power on the planet to have GPUs at base station sites. But to be able to, and for their perspective, it's to be able to know everything about every bit that's being transmitted and received, and to figure out how to optimize the modulation and whatever's happening in that channel state to improve it. And the question is if I can improve it, if it's less than 20%, do I even care, given the amount of energy I'm going to spend to get that 20%? And so I think there's going to be a lot of practical POCs that are going to be coming out to understand, okay, I made it work with AI, but it cost me 100 megawatts to do that. Is it worth that energy and the price of that energy to improve my performance by that 10%? And I think that's really where the rubber is going to hit the road on the AI stuff as we look at release 18 and beyond.
Yeah, that's a very good point. I didn't even think about the part of the processing power that's wasted if you don't get a great improvement. And so you just did an update on your macro base station antenna market. Can you tell us about that? What trends should we be aware of?
So there's a lot of really cool things that have recently been announced, specifically by Ericsson in front of MWC. One of them has been what we call active passive antennas, where I have metamaterials or invisible materials to certain frequency bands that I'm using. And in the case of what Ericsson unveiled, it was their integrated antenna 8000 series. Essentially, it is a big low band passive antenna with an FDD massive MIMO and a TDD massive MIMO unit bolted behind it, and completely part of the unit as a complete integration. And so those units are transmitting their mid-band and C-band radio waves that are completely transparent to the low-band radio waves that would be part of the actual antenna that would have traditional feeder cables and jumper cables attached to macro radios below that particular unit. So that is the ultimate level of integration that is now being unveiled. It's not for every site. And it won't be for everyone, but there will be situations where that is warranted. Again, a lot of the sites that are out there today have only one pole mount. And so if you only have one pole mount, then this is a solution. But if you don't have one pole mount and you have multiple pole mounts, then I think that level of integration also comes with risk. If I need to change things, will it fit the next time I want to swap out something? If I want to change anything with the massive MIMO radios, if I want to change, or if I add another low band frequency, is the antenna going to be able to handle that? And if I need to make any change, the whole thing now has to come down or be disassembled and replaced with something else. And that is extremely costly relative to just replacing a passive antenna panel. So that's one thing. Hybrid multi-beam antennas, I think, is another trend, and that this relates to the issue for mobile operators about what is life after massive MIMO. How do I add more sectors to my site, but they still look like 3 sectors to the naked eye and to the tower company that they're leasing this space from? So virtual sectorization versus adding a delta sector and doing 4 sectors, I think, is certainly a continued trend. We've been seeing it, but most people can't tell the difference when they look at an antenna to see, is it a single beam antenna or a dual beam antenna or even more than 2 beams? And I think that is the way where we're going to start to see this evolution of maybe going back to the passive antennas after we need more capacity than maybe 4 layers of massive MIMO. And then what do we do next? And all the antenna guys are starting to look at multi-beam antennas that could be used in a macro. Today, we have them in stadiums and events, but those things are way too big to stick on a tower. And so how do we get that stadium capacity moved in a smaller form factor over to macro towers in order to implement and create these additional virtual sectors that the carriers are looking for?
Let's dig into that in a little bit more detail if we can. Antennas and transceivers have a symbiotic relationship, right? A communication network needs both to close the link. So how are the antenna developments you just mentioned influencing and being influenced by the transceiver? What do you expect in the future for antenna and transceiver architecture?
That's a great question, Eric. And they are symbiotic. And prior to COVID, back in the late 2018, 2019 timeframe, everything was single band radios. So assuming you had a 4T4R radio, you needed 4 antenna ports on an antenna. And that was if you wanted a specific tilt for that band and for the service you were offering. And we started seeing 24 port, 28 port FDD types of antennas because we had so many radios that were single band that were all 4T4R. The evolution of the radio obviously went a different direction. Instead of adding more single band radios, we started seeing multi-band radios. And the multi-band came about because every operator around the world sold all of their tower assets to someone else, and now they're paying rent. And so every piece of weight and wind load on that tower now is extra rent for that operator. So the goal now is to reduce every box to 0 if you can, but you can't. But we've seen now 3 sector types of radios that have 12 ports on them. ZTE was one of the first to unveil that. And I think it was 1,200 watts of RF power from that one box. And it was a suitcase. We typically see multi-band sector radios, whether they're triple band low band or dual or triple band mid band radios. So that evolution has completely turned the antenna world upside down because now I need less antenna ports. And in an ideal configuration of 4-port low band and 4-port mid band, I only need an 8-port radio. Assuming, again, I don't want tilts for every one of the sub bands and whatever, and everyone's happy with the way it is. And so an 8-port radio today is extremely commoditized. There's not a lot of value compared to a 28-port radio that everyone was developing pre-COVID. And so the direction now is we've been trending down in the port count. But as you said, radios impact antennas and vice versa. So I think antennas are more lagging to the radios. The radios now that we see in North America, particularly with AT&T and Verizon, there are now 4T8R radios instead of 4T4R for midband because I need more uplink on the cell edge. And again, everyone's focus is on uplink. Forget the downlink. You can blast enough power to hit any UE out there. It's how does the UE talk back to the tower becomes a question because everyone's not going to wear a man pack battery in their backpack to power that cell phone. So the US is probably one of the first to go to 4T8R. That's great for the antenna guys because I need 4 extra ports now for my radios. Instead of 4, I need 8. And if I keep with the 4T4 on the low band, now I need a 12-port radio, which is way better than an 8-port because every port is more dollars. Are we going to go to FDD 8T8R? I don't know. China has been adopting it, some European countries, and operators have been adopting FDD 8T8R. I think Ericsson would rather have you go to 32T massive MIMO and forget the 8 because they want to sell massive MIMO. And it's really going to be up to the operator to figure out where is that evolution, because it always seems like everything we skip, we go back to. And case in point, we skipped 16T because everyone thought we didn't need it. And now people are deploying 16T. We skipped 8. I have a feeling that at some point we'll have 8 in whatever flavor, whether it's 8 receive, maybe 8, not 8 transmit, but we're still going to have 8 ports on an FDD radio that's multi-band. And all of this is good news for the antenna guys. The Europeans are also looking at the 1400 megahertz band that they have there for supplemental uplink or downlink. So all of these additional sidebands are happy times for the antenna guys because there are more additional ports that you need to have to connect those specific radios to the antennas. Also, there's been a lot of movement and integration towards FDD TDD, or what we call a hybrid antenna. So if I have a 8-port TDD radio or 9-port with the calibration port, I want one antenna that does both FDD and TDD. And there are lots of antennas now that do this hybrid configuration. Initially started out of China and started to spread elsewhere, where we have both of those combinations in play. And even T-Mobile, because they have band 41, if you're in a rural market, they could easily use a traditional 8T8R TDD radio. They don't need to put a massive MIMO radio there, and they could hook it up to all their FDD bands and use one of these hybrid antennas. So there's a lot of technology that we're still starting to see. Green is one of them. How can we be more ESG sensitive, I guess, is one way to put it. Every operator has these goals of reducing their carbon emissions to be more green. So if you look at any of the annual reports, they're always talking about adding solar or doing all of these other things to be more green for their sites. Antennas are part of the supply chain, and just like radios, they want their antenna suppliers to have more green of everything inside the antenna. And green also means money, more efficiency. If I can do some of these waveguide types of feeder networks inside and reduce the amount of coax that I have, that reduces the weight. It increases the amount of recyclable materials inside the antenna, the radome material. Everyone's moving away from fiberglass to some other type of more green technology for the plastics on the radome. So there's a lot of stuff happening behind the background for antennas. But like you said, antennas are now probably one of the most critical parts of the tower besides the radio itself. And if your antenna is not efficient, then it's essentially destroying all of that wonderful RF that the radio is creating.
We're seeing a lot of activity in non-terrestrial networks, either with direct-to-device opportunities or how those networks are becoming more important in a unified wide area wireless network. What are you seeing in those areas, and what can we expect in the future?
I think certainly everyone knows what Starlink has been doing and what they are continuing to do in terms of direct to cellular types of connections with their latest satellites that they're launching. So all of the LEO programs that are out there, whether they're from the Europeans, the several Chinese constellations that have been put onto paper and starting to launch as of last year, as well as what's going on here in the US with the many different constellations that are out there. So everyone's trying to get into the game, and certainly it's probably a great time for SATCOM players and for semiconductor companies that are making the products that are going into all of these birds that are eventually going to be launched. I think the question is, what type of service are we really realistically looking at for the consumer, and what types of consumers are actually going to want this particular service from the mobile operator? And even the Geo SATCOM guys are getting into it. But again, for the Geo guys, you're going to get a text message, and that's pretty much it, given the data rates and how far up in the space they are. But for the LEO guys, is the expectation that you're going to be watching Netflix over a satellite link on your phone? I don't think so. I think initially what we're going to see is a service offered by T-Mobile or whoever that says you can buy satellite service for the day because you're going to go hiking and you don't want to die. And something happens out, you can make an emergency 911 phone call to get someone to come out and save you. If you want Netflix, you're probably going to want a bigger antenna and a service like Starlink officially, and you're going to want to carry that antenna to wherever you're going to be camping in the middle of nowhere if you actually want your Netflix. But I don't think it's going to happen on your handset. And I don't think it's realistic to assume anytime in the near future that we're going to see that level of service that's going to be operated on the phone. So then the question becomes, who wants this service? I think people who are very outdoorsy will probably be your first movers in signing up. Is it going to be better than a Iridium phone where it has a 1 foot antenna that you can swing out. No, it's not going to be better than that, but it will be good enough for the applications, which is essentially right now emergency services and 911 calls where there is zero cellular coverage, and where without that you will probably die.
Well, on that cheery note, let's switch gears for just a second, and important topic nonetheless. I see that Huawei just released their FY24 financial results, their year-end results, and they were pretty rosy, despite the targeted technology sanctions that the US and allies have imposed for some time now. And not included in those results, of course, are the broad trade tariffs that have recently been imposed. So what are your thoughts about the effect of these geopolitical tensions on the technology sector?
My personal feeling is we should have just slapped the fine on Huawei and called it a day. I don't think the strategy of trying to kill them off completely was wrong. And all it did was lose a lot of money for US semiconductor companies way back when this started, because Huawei was their biggest customer by far over any other company on the planet. And if you go back and look at the financial reports back in that time frame, they didn't list the company, but that first company in the top 5 was Huawei. And so what we've done now is we forced the entire US semiconductor industry to say, I can no longer sell anything into China, which is the biggest market for everything related to electronics. And I have to now seek customers elsewhere to make up for that Grand Canyon that you just imposed on me to fill. I think the other issue is that people don't understand or didn't understand is the amount of capability that a Chinese company such as the size of Huawei has. Back a couple of years ago when I attended their analyst event, they talked about the fact that when the sanctions were imposed, they redesigned, I think, at least 5,000 printed circuit boards with all new components that they could get that were not on the sanction list. And I can't imagine any company having the capability of redesigning that amount of systems and getting the components. And now with the advent of their reliance on SMIC over there as a foundry instead of using TSMC, I think that you can't overestimate or underestimate the capabilities of the people that are over there in China on a tech side and what they can develop. And given that fact, Huawei should be dead, but they're not, and they're doing better. So then the question becomes how? I think part of it, obviously, in the first several years, they banked and inventoried so many chips and over ordered, and every chip guy was so happy, not understanding that this was for later and not for that year. And so the numbers were off the chart if you look back then on what everyone was shipping into the market for RF components. And people were not questioning that until we figured out what they were doing that for. And that bought them several years of time to redesign everything, like I spoke about, and then to get back on track with the semiconductors that they could get access to, with the process nodes that they could get access to at SMIC. And now that they've had many years of working on that and refining that, I think the question is yes, it's still hurting them. They're not at the level of the state of the art that the other players are at in terms of, the 1.8 or 2 nanometer or whatever that's below what we're looking at in the 5 to 7 for SMIC. But it's certainly not hurting them enough to where it's changed the game. And I think the question now as we go forward is, with all the focus that's in China right now on semiconductor processing and on EDA tools and software and everything else that they're working on, do they really need anything more from ASML? Sure, they would love to have it. I don't think it's killing them by not having it. And I think more than likely they will overcome it in some way, shape, or form, and things will continue to move forward. And so I think there was a lot of hope that there was going to be a huge dent on Huawei. And yes, there was initially, but they recovered from that bottom and they've been able to reorganize and do everything else. And I think now the question is how does the rest of the world continue to react to that, or specifically in the US? And I think the geopolitics also play into the roles of analysts in terms of access to what we get to see and who we get to talk to if we're based in the US relative to being based elsewhere internationally with the Chinese players.
Well, Earl, we've covered a lot of topics in our discussion, but any important ones that we've missed? What's going to drive the wireless infrastructure market, and what do you think it will look like in the next 5 years? And how do all these topics fit into the wireless network of the future?
I think we have to look at the market, or whoever is listening to this event or watching it has to understand that the market has two pieces. The piece where I get to play in China and the piece where I don't get to play into China. And if you haven't figured that out yet, then I'm sorry. But that is where the game is today. And depending on if you're playing in one side of the game, it's not going to look as good as the other side of the game. So let's start with China. China is moving ahead with what they call 5G NR Advance. That in their definition means 10 gigabits per second to your handset. And the way you get there is not through C-band, but it's through a combination of C-band and millimeter wave. So my expectations at some point, hopefully in the second half of 2025, MIIT in China approves millimeter wave for all of the mobile operators. And then it will be off to the races in terms of 26 gig chipsets and radios and everything else for China as they start to ramp up and deploy their 5G NR advanced networks. So things will be rosy in China. If we look at the rest of the world, not so sure. We have a bunch of issues with N102 spectrum, which is the 6 and 7 gigahertz. That's been approved from WRC 23 for everywhere in the world, including China, except for the Americas. So the Americas from Alaska to the tip of Argentina and Chile is a black hole. And 5G Americas has gone through the ITU with the notion that maybe the 7-8 gigahertz band could be utilized for the Americas, since we let the Wi-Fi guys have a complete takeover of the 6 and 7. My personal feeling is that we should take back the 104 and leave them with the 102 and be happy with it, but I know that they're not going to do that. So from a regulatory perspective, the Americas is kind of screwed for the time being, and everything's up for tables and up for grabs and discussion at WRC 2027, which is 2 years from now, which means do I do R&D work assuming that 7-8 gig actually comes to fruition after the 27 event? Or do I wait to see what I do for my R&D, or how do I approach that? And the same thing with FR3 in terms of the 8+ gig to the sub 24 gig band. Fixed wireless access would be great. It would be hopefully a better incarnation of LMDS, but in a much more efficient way. And 13 gigahertz is way better than 28 if you want to do FWA, just from a cell size perspective. And I don't think FR3 is something you stick in a phone. I think it'll be a CPE, and it'll be a piece of network radio equipment that we're going to be doing for a massive MIMO or massive antenna element at the microwave band. So there's a lot of hope on that. And there's a lot of technology that's being discussed for 5.5G and 6G technologies. The problem is, from my perspective, who has the money? I don't see a lot of operators right now focusing on CapEx. What they're focusing on is debt reduction and paying off the debts that they have on their balance sheets. And does Wall Street want Verizon and AT&T to spend another $100 billion on the next spectrum auction for 7 and 8 gigahertz, and then to spend another $20 to $40 billion building out a 7-8 gig network? And how much revenue are they going to get out of this thing? And again, what are we going to see as applications? We're still looking for some of these monetization and applications for 5G, and we haven't seen it yet, at least from a consumer side. So if the business side is going to be moving in that direction, is that too big of a risk for everyone to look at? Or is it going to be, I have to continue to play because it's table stakes, and if I don't play, I'm going to be considered out of the race? So I think it's going to come down to a lot of money, but I think also timing. This every 10-year cadence that we've had is it broken now? There's a lot of talk about that. There's a lot of speculation that maybe we just need continuous upgrades of the network that doesn't have a G attached to it. Not really sure. That's out of my pay grade. But I think the ultimate thing is for the operators right now, their pain point continues to be capacity and coverage. So I'm going to continue to invest in the radios and the technologies I have today. I'm not going to have a new waveform for 6G. They're also not going to do NSA because they learned their lesson about what a stupid idea that was in 5G land. And so everything will be SA from the start in 6G. But I think, like always with anything in wireless, is going to be timing. And maybe it'll be pushed out a little bit after 2030. We'll just kind of have to wait and see once we get to the majority of the operators around the world, at least to SA, and hopefully making some money from the businesses and all the other stuff that was talked about in the early days of 5G that's not consumer dependent. And then we'll see what happens with the rest of the world. So I think it's a more bleak outlook from my perspective right now if you're not in China, at least for the next several years. But that could change on a dime depending on if someone comes out with something great that everyone thinks that they need to have.
Well, thank you, Earl, for sharing your thoughts with us today. It's been a very informative talk, as always. We look forward to catching up with you again in the future and get some more insights, maybe after Mobile World Congress. To our listeners, please give us a like, and you can find more podcasts at podcast.microwavejournal.com. Thanks for listening.